So the 3D printing solution we have is to reduce the vibration of 3D printers. And why do we want to reduce the vibration? Because we noticed that even though the printers could, in theory, travel faster, because their models can actually push them faster, but one thing that stops them from reaching those speeds is because they vibrate when you push them faster, and that vibration causes loss of quality. And so what we did was to address that problem of vibration by figuring out a way through software to compensate the vibration, and that allows us to travel faster without having to sacrifice quality. I came to the University of Michigan. We started research with my students working on that problem, and a couple of years later, 5 years later, was that solution. So what we've got here is a 3D printer. There are different types of 3D printers, and this one is specifically called the FDM, Fused Deposition Modeling 3D printer, and it's one of the more common ones. How it works is you've got a part that you model in the computer, and after some processing, it sends commands to build that part layer by layer by depositing material layer by layer, and that's what you see here in the video as it's depositing. Now, to deposit the material, it has to move the nozzle that is extruding the material, and sometimes also the plate on which the material, the part sits, to be able to create the motions. And that's where we have the problem of vibration, because when you have a part as intricate as the one we've got here, or maybe the one printing, then it means that the machine has to do a lot of back and forth motions to change direction to create this intricate part. Now, as it changes direction, to do that quickly, it has to accelerate and decelerate fast. And when you accelerate and decelerate fast, then it causes vibration. And one of the sources of vibration is the fact that many of these printers, to keep the cost low, use belts to transmit motion. And the use of belts, then the belt is a source of flexibility, and so it causes vibration. And so what our algorithm does is then to change the motions of the model slightly, ever so slightly, so that this vibration are avoided. And that way we can push the machine faster, accelerate and decelerate faster, and still get very good prints.
I was actually tasked to actually do the implementation of the theory we co-developed with my lab mates. So as a part of the implementation, we had to do we had to break the entire trajectory into many small pieces, and then we do the optimization online, so that we can actually put in a 3D printer, and then we can print for hours. So as a part of the process, we had to use the real-time capability of dSPACE, so that we have a fixed sampling rate of a trajectory, and then we create the optimal control signal for a given trajectory at that specific chunk. So what we do is that we break the trajectory into many chunks, and then we seamlessly patch those chunks, and then at the end we have a trajectory that doesn't create much vibration. So the algorithm is all implemented in Simulink, but then once it's compiled into the dSPACE controller, we have to communicate with the controller with its control desk. So in here we have a graphical user interface that shows the XYZE coordinates of the printer at current time, and also the various status light or control buttons, so I can turn on and off certain features. It also has a capability to measure and record some of the sensor we actually mounted on this printer. So at the end, we have a data file, and then we can analyze afterwards what has happened.
Yeah, so this is the MicroLab Box, dSPACE MicroLab Box, and the main difference between the MicroLab Box and the other dSPACE systems that we have in the lab are that the MicroLab Box is a lot more portable, and it's very compact. And so we have our digital pins here that are going to go out when we're sending out our stepper motor commands to actually control the printer. And then when we're identifying the printer, we can actually use these analog pins to collect the data from our accelerometers directly. And so we don't have to move anywhere. We don't have to have external cables to any other pins. It's all right here in the MicroLab Box.
We are really, really happy. We were actually pleasantly surprised by the improvement that is showed through the software. We're about to start a trial phase working with a company to place this on 3D printers and try them out over different types of 3D printers to see how well it works and to see if there are things we need to do to improve it. And so we are really on the path towards making this available to everyone to use.